Okay, welcome to a new video, guys. This time I am going to walk you through sections 12, 3, 5, and 6, where we need to figure out every single detail of the triangle congruence theorems, okay? I want you to pay attention. I want you to pause the video if necessary and rewind it a little bit to try and understand any single thing you don't, right? The first thing I'd like to mention is that there are four of these congruence theorems for triangles, and they have specific names, and I'm going to walk you through each of them to make sense of what they mean and how to understand them, okay? So, these four theorems are the SAS. S stands for side, A stands for angle, so we have the side, angle, side, and remember the order of these letters is important as well. The second one is side, side, side. The third is ASA, and the fourth one is AAS. Okay, so what's the meaning of this? I want you to take a look at the first pair of triangles I have here right below these lines. And look at the triangles ABC and triangle DAF. Okay. If you see those triangles just like that, you might see, well, they look really similar. They might be congruent, okay? But we cannot just rely on the visuals, okay? On the, it looks like part of it, okay? So the thing is that I am going to start working on some of the marks of congruence to eventually figure out what the meaning or how to understand these theorems. Okay, so let's begin with explaining theorem number one. We're going to see how to understand what SAS mean. So as I told you, if you look at these two triangles, if you know they look really similar, but they are not congruent. But this is what I'm going to start doing. Hopefully you can see that, for example, segment CA and segment DF are, remember the word, corresponding, so they are occupying the same place or position in each triangle. The thing is, right now they are just corresponding, but now I'm about to make a mark on them, and let's use blue. Now let's use green. Sorry. So this time, if I write this mark and this mark over here, now I can say that segment CA and segment DF are what? Are congruent. And this is congruence of one of the sides. But right now, that's all we have. So I cannot make a conclusion that these two triangles are congruent. Just a pair of sides. That's all. One side per triangle. Now, please take a look at this S right here. I started with this. Now I'm going to pick one of the angles, but this time I'm going to pick one of the angles that are formed by segment CA or by segment DF. Sorry, I didn't write this. Okay, so look at this. I'm going to choose this angle A right here, and notice that the corresponding angle should be angle D. With this mark, now I can say that angle A and angle D are congruent, and I am talking about one of the angles, okay? And as I mentioned at the beginning, the order of the letters is important because now I want you to take a look at angles A and D. On the left triangle, angle A, and I'm going to use another color here, let's use yellow. Angle A has been formed by intersecting segment CA and segment BA. Okay? Now, with that in mind, then the next segment I'm going to choose here is segment BA. And as you can see, segment BA and CA are forming angle A. What I'm going to do now is I'm going to draw a mark with two of these tallies, right? What is the corresponding side to BA on the other triangle? It is DE, okay? DE. And I'm going to write this mark to indicate now that segment BA and segment ED are congruent, but they happen to be the second segment forming each of the corresponding and congruent angles D and A. So it means that this is the third segment here, or the third element. Once I establish that this is true, and I have SAS, meaning that the congruent angle is the one right in between these two sides, just as you see here. Can you see angle A is right in between B and A, and angle D is right in between DF and DE or ED? Now I can make a conclusion. If these three happen to be congruent, then my conclusion is that then triangle ABC is congruent to triangle DEF. That's what we're looking for, and I could show that by the SAS theorem. That's how we use those theorems. As long as those three specific elements are congruent, then I can now conclude that these two triangles are congruent. Now I'm going to walk you through the other three theorems, but hopefully this is going to be easier for you guys, because now look at this. Same thing. Look at these two triangles. Now we're going to figure out the SSS. This one is really simple and easy because, okay, so AC is corresponding side to DF, correct? But right now they're just corresponding. But remember, if I draw this mark right here, this mark right here, now I can say that these two are congruent. This is one side. But now I'm going to do the same thing with the others, right? Okay, so this is going to be AB and DE. Right now they're just corresponding. But once I draw these marks, I am also saying that these two segments are congruent. This is another side. And we just need to finish by stating this. That if, as you can see it from the figure, BC and EF are congruent, and this is the other side. Can you see the SSS part of it? I can say that if this is true, if all of these are congruent, then triangle ABC is congruent to triangle DEF. All right? Can you see the correspondence here as well as I write their names? That's also important, guys. Keep that in mind. All right, same thing. Let's take a look at ASA now. So question, right now, are these triangles congruent? They're not. They're not because nothing is indicating that they are congruent. But let's begin. I know that AB and ED are corresponding, right? But now, oh, I'm sorry. Okay. So now we're going to AB and ED are congruent, right? So are corresponding, but now I'm going to make them congruent. All right? I am also going to make congruent these two angles, as you can see. All right? So now I can say that if these two are congruent, I'm talking about a side. But can you see that this side is in between two congruent angles? In this case, wait just for a moment, okay? Angles AE and angles B. This is an angle, and angle B and D. Can you see how it is formed now? So now, taking into account two different angles and the segment in between these two angles, triangles, sorry, ABC and DEF are congruent by the theorem ASA. That's how it works, okay? Finally, we're going to do this. And now you know how the game works. So, angle B and angle E, angle A and angle D. But now this time is not the segment in between. This time is the adjacent segment to them. Then what we have is this, all right? So since angle B is congruent to angle E, angle A is congruent to angle D, angle, and then finally segment AC is congruent to segment DF, AAS, you can see how they are being formed. We can say that triangle ABC is congruent to angle DEF by the AAS theorem. I'm going to pause it here because now the second part of this video, what are we going to do? We're going to work out some exercises dealing with these theorems, okay?